Welcome to the National Museum of the United States Navy. I'm David Barker. I'm an educator here. I'm going to be introducing our speaker today. His name is Chris Strong. He is the Warning Coordinator Meteorologist, the WCM, for the National Weather Service Baltimore, Washington Forecast Office located in Sterling, Virginia. His forecast office serves all of Maryland and the Chesapeake Bay, as well as Cecil County in Maryland, Northern and Northwest Virginia, Eastern West Virginia, and the District of Columbia. As the WCM, he is in charge of outreach network for his office and ensure the National Weather Service program, forecasts, and warning are effectively used by the government, the media, and the public at large. Ladies and gentlemen, let me introduce Chris Strong.
Hello, everybody. I'm Chris Strong, and we're going to talk a little bit about weather, the history of weather forecasting, great sources of information to make sure that you stay safe from weather. I mean, we know we get just about every kind of weather threat that we can have here in the Mid-Atlantic, in particular, in the DC metro area. So a big key thing is just knowing how to get weather information to you quickly, because just about everything comes with a little bit of advance notice in this day and age. And if you have that advance notice, things are going to turn out so much better in the end for you, for your family, for the community. So getting that tornado warning, getting that note that there's a winter storm headed towards the area, extremely hot conditions, flash flooding, all these different things that can happen. If you have that ammunition of knowledge that there's something coming on the horizon, you'll be able to prepare for it. You'll be able to prepare your family and your community for it, and everything will turn out so much better. But it hasn't always been that way. So, what's the weather going to be has changed a lot over the decades, over the centuries. For a long time, for most of human history, if you asked what the weather is going to be, unless there's no change, there really can be a little bit of skill in that first day, in those first few hours, because you can look up at the sky, you can look at the clouds. And especially if you watch it every day and have some skill in it, you can have some knowledge as to what's going to be happening that day, or generally that first 12 to 24 hours. But past that, other than that, weather really relies on weather that's ongoing in places other than where you are. Unless things are not changing, weather is going to be coming at you from a different direction, from another location. So if there's no communication, no way to know what's going on in St. Louis or Ottawa or the Bahamas, if you don't have that source of information, as most of the human history, we didn't have that way to communicate quickly that weather information. There was no way in saying of what was going to be coming towards your area. The result of that was that there was no time to plan or prepare for weather disasters. So mass fatalities from hurricanes, from tornadoes, from flooding, from gales at sea, would happen routinely, and many people would perish from weather threats because they would either go into weather and weather threats, or the weather threats would come to them without any knowledge or foresight. So for decades, for centuries, for a long time, mankind was really limited to what's going to happen over the next day or so. Anything that was past that was just a surprise. So what sparked the advance? It really was the invention of the telegraph, which really allowed us to share weather information from other locations to where we are. It was really kind of the internet's grandpa, is the way I heard it described once, and I think that's a pretty telling thing of what it was. Is it really helped information from one part of the country get to another part of the country very rapidly, and that worked for a lot of different industries, and it worked well to advance a lot of things. And one of those things was weather. Here's a weather map that was drawn in 1870, and the way that they were able to draw where areas of high pressure were in the country, where storm systems were, and temperatures, and how that was all across the country, was because they got all that information by telegraph. So it really made a jump in really started modern meteorology by allowing us to share this weather information from across the country, from even across the world, so we could begin to see what's out there, what weather is lurking that's eventually potentially going to be coming in our direction. Here we see Cleveland Abbey back in the late 1800s. He was the first chief meteorologist of what was then the U.S. Army Signal Service Corps. And that was going to ultimately become the U.S. National Weather Bureau, which became the National Weather Service. And he made a bold quote back for the late 1800s saying, "We do not propose to guess at weather. We leave that to the almanac makers, like Farmer's Almanac is now. But we shall be able to assert the nature of weather up to 4 days in advance." That's pretty bold for way back then when they were just starting to get this information and learning how to process it. But that's where we started. And this was kind of the beginnings of modern meteorology back here in the late 1800s. In the decades that followed that, modern day meteorology really advanced, and we became aware of these storm systems that were out there. We began to learn about them and what causes them to go in different directions. We began to have things like weather balloons that could go up in the sky and let us know not what's just going down here at the ground level, but what's coming in from the clouds. You know, what are the temperatures up there? What are the winds that are, you know, thousands of feet up in the atmosphere? And we'll get to that a little bit later in the presentation too. But it was really just this constant observation, which works not only for meteorologists, but for you all as well. If you constantly watch the weather day in and day out, you're going to learn about it, just because you're going to see all the different things that can happen and what tends to be in advance of this or what tends to follow that. And that's really just how the science started to advance as we went through those early decades in modern meteorology. And what I call the stool slide here. How does weather forecasting advance, and why does it continue to get better over the years? Well, it relies on three things. If you think about the accuracy of the forecast or the quality of the forecast as the seat of that stool, the legs that hold it up are three things: their observations, their computing power, and their forecaster knowledge. And all three of those have grown pretty radically in just a few generations. You think about just from the observation side of things, we've gone from just being able to see, you know, what's going on here at the surface at a particular location and marking that every day. You know, what was our high? What was our low? How cloudy was it? How much precipitation did we have? To now, we not only know what's going on with increasing clarity in multiple spots across a county, let alone you know, a region of the country. We know what's going on through the clouds, through radar, you know, utilizing tools like radar and satellites. Airplanes that are cutting through the sky are constantly measuring weather information. A lot of those are getting back to the National Weather Service to use. So our observations are constantly getting better. We've gone from very limited knowledge of what's going on right here at ground level to a whole sea of information as to what's going on. You could go online right now and probably go to your child's school and see what the temperature and winds are there, or, you know, what at the nearest highway, what's the weather sensor saying there? You know, the satellites that are looking down on us from above are seeing with increasing clarity, you know, where the clouds are, where the storm systems are, and how they're moving. So that's one side that's certainly radically grown over the years. The other thing is computing power. In order to forecast the weather is very much just a fluid, and it follows the rules of physics. It follows the rules of fluid dynamics. So if you know to an exacting skill what's going on right now, you'll be able to step it forward in time and say, all right, this is where it should be a minute from now, an hour from now. And in order to do that, you need to make calculations and computations. And they used to have rooms full of people that would say, all right, here's the weather at a few spots across our country. Let's use the laws of motion and fluid dynamics and figure out how things are going to evolve over the hours and days ahead. Well, we've got a lot, you know, gone quite a distance from people in rooms to computers that fill rooms in order to do that. So computing power, the ability to process weather information, has grown radically over the years. And then forecaster knowledge. With each storm and with each advancement in technology, we continue to learn more and more as scientists to be able to see what weather systems are going to be able to produce and to be able to give advanced warning on them. So observations, computing power, forecaster knowledge, they've all grown. They're all continuing to grow. That's why weather forecasting continues to advance year after year. And you know, the forecast that you got 10 years ago are not nearly as skillful as they are now. And the forecasts now aren't as skillful as they will be 10 years from now, because all these things continue to advance. It shows you just kind of a couple of the mathematical equations and physical equations that meteorologists use to forecast the weather. And these are equations of motion. But like I said, the atmosphere is a fluid. It behaves in predictable ways. If you perfectly knew the characteristics of every little bit of the atmosphere, you could make a perfect forecast. So why don't we have a perfect forecast? Why don't we know every little bit of the atmosphere? Well, and start a little bit about observations. We do start with what's going on right now. And again, we use satellites, we use weather buoys that are at sea. We use observation stations across the country. We use weather radar. And in the middle there's a weather balloon launch that goes on. And we still do weather balloons after all these years, because it's a great way to get a weather sensor into the sky fairly cheaply. So twice a day, not just at our forecast office, but all across the country, all across the oceans with ships at sea, all across the world. If you were on a satellite and could see really well onto the planet, you would see twice a day these weather balloons going up into the sky all around the planet that are measuring the temperature, that are measuring the winds, that are measuring the humidity and the barometric pressure. And that's part of our knowledge base as to what's going on in the atmosphere right now, is these weather balloons that go up twice a day. So that's just one of these technologies that's held on because it's so effective and a fairly low cost way to get what's going on, not just here at the ground level, but what's going on in the sky, what's going on in the clouds. So if we step forward, we'll start with these observations now, and we'll use those equations we saw a couple slides back, and we'll be able to model if it's 37 degrees here right now, and it's 39 degrees 10 miles away, and 41 degrees 14 miles away, and the winds are this direction in particular, and the pressure varies like this across the area. You'll be able to fill in all these variables in the equation and figure out what's the temperature going to be a day from now, what's the wind going to be like 4 days from now, how is this hurricane in the open Atlantic going to potentially affect the Southeast United States and the mid-Atlantic up here. So those observations give us the starting point, and then those physical equations, those mathematical equations, take that starting point and then figure out how that's going to step forward in time as we go through the minutes, the hours, the days ahead. And we talked about, if you have every little bit of information on what's going on in the atmosphere, you could have a perfect forecast. Well, the reason we don't have a perfect forecast, most strikingly, is because we don't know every little piece of the atmosphere, and even some of the parts that we know have errors in them. So there's errors in observations that come in from time to time. There's missing info for one reason or another. And there's bad information that makes its way into the system. And certainly we're not measuring every molecule when we do a weather balloon twice a day across the country. If we did weather balloons every minute at every little point across the country, we'd be getting closer. But obviously, if we're doing one weather balloon here and we're doing another weather balloon in Pittsburgh, there's a lot of space in there for things to crop up that we don't see, that we don't measure directly. So it's things like that that allows missing information, errors, and things like that to slip into that initial snapshot as to what's going on right now. And then once again, you throw these into the models, these equations to step forward in time, it's the butterfly effect. Those little errors that start out at first and those little missing pieces of data start to amplify and grow bigger and bigger and bigger as you go through time. And that's the reason why the forecast for today is much better than the forecast on average 3 days from now, which is better in general than the forecast 7 days from now, because those little errors that you start with at the beginning get bigger and bigger as you go through the forecast, as you go through time. So I think that'll be one thing that we'll always have is the 1 day forecast, the 6 hour forecast is always going to be the best forecast. And then that slowly gets fuzzier, or understanding of what's going to happen in the details gets fuzzier and fuzzier and less certain as we get further out in the forecast. So anytime you're watching a storm and we start to see, hey, there's a potential for snow 5 days from now, As that gets closer and closer and closer to us in time, we're going to have increasing certainty, increasing detail, increasing understanding of what's exactly going to happen with that storm as we get closer to it, because that error gets minimized with time. So in order to truly get a good handle on how the atmosphere is behaving, you got to start with the wide view and narrow it down from there, or zero into the area that you're concerned. So if you start, if you're just interested in what's going to happen in Washington Metro, and you just look at Washington Metro, something's going to creep up on you from the mountains or from the Midwest. Even if you take a bigger view and just look at this region of the country, there's going to be things that crop up on you from the north or the south or the east or the west. So we really need to start with the biggest possible view. And for us here in the Northern Hemisphere, that wide view is the Northern Hemispheric view, where you're looking down at the globe from the North Pole and you're seeing all of these lobes of cold air that are extending down from the Arctic, all these warm noses of air that are extending up from the tropics, and the storm systems that swirl them all together and cause a lot of our big weather events that we have. So when we look at the hemispheric view, we're looking at the positions of the jet stream, where these cold air outbreaks are coming in, where the warm noses are nosing up from the tropics down from the south, and how those are changing over time. And these big picture, large scale things are going to be what drive smaller scale things that are going to be our ultimate mission and what we're trying to find. And we narrow in on a more national scale. Now we can start to see a little bit closer on the area of concern for us, for our locality. We're going to start to identify individual storms, individual disturbances across the country, how they're moving, things that are associated with cold fronts, warm fronts, and their movement and how they're changing as they move across the country. So we've gone from the big picture view on where the big weather features are. We're down to the national view. We're starting to see individual features that are moving across our country and potentially towards us. And now we're getting down to a more regional view of our particular area. And from here, down at the regional perspective is where most of the things that are sensible weather happens. Exactly how hot it's going to be, how much snow we're going to get from a system, how much rain we're going to get from a system, from individual thunderstorms. A lot of that local variation is what you actually feel from day to day. And a lot of things can drive that. It's not just the big picture things like cold fronts and big major storm systems, but it's little things like bay breezes that move off the Chesapeake Bay, or even the tidal Potomac River into the DC metro area that cool things down right along the river shore. It's individual thunderstorms that put down a gust front of cooler air or refreshing air from higher up in the atmosphere. So it's all of these things that we're looking at holistically. We start at the big picture as meteorologists, looking to see where the big things are. We zoom into the national scale to see where individual storm systems are that are driving individual storms. And then we go down to that smallest view, the regional view, even the local view, that shows where individual storms are, how they're moving. And that allows us to make our forecast for our area while still taking into account what's all around us and can move in as we go through the days ahead. So what makes the elements of a forecast? The basic weather observation or forecast, since again, they're tied. If you start with the observation, you can move it into a forecast. So any good weather observation or forecast is going to be comprised of temperature, the humidity, the cloud cover, how many clouds, how overcast the sky is, precipitation, wind, and whether there's any obstructions to visibility like fog is. So in the process of making these forecasts day in and day out, what we at the National Weather Service in particular are looking for is what's hazardous. What do we need to warn people about? Because having a forecast is great and it allows people to live their lives effectively day in and day out. But when it comes to life safety and keeping people safe from weather threats, we need to warn people when the winds get too strong, or the temperatures get too hot or too cold, or when the precipitation intensity gets too much and we're starting to have flooding. So that's one of the big things that we're always watching for at the National Weather Service. And there's no shortage of hazards. Everything from severe damaging thunderstorms that put down damaging wind gusts all the time, especially here in the mid-Atlantic. Tornadoes, flooding and flash flooding, hurricanes, dangerous wildland fire conditions. We work very closely with wildland firefighters, so they need to know when conditions are getting extreme for their mitigation efforts. Wintry precipitation, coastal or tidal flooding when the tides are getting exceptionally high are going to start to cause problems and potentially even come into people's homes. High winds, whether it's land or marine. One of the first slides we talked about gales spinning up on marine areas and boats and ships at sea driving into these gales. One of the things we're always forecasting for is our boating community, to keep them safe from strong winds, whether they come from individual storms and thunderstorms or whether they're big sprawling storm systems. We've gone a long way as meteorologists to keep them safe from these things that can spin up over marine areas. Extreme temperatures, again, whether it's too hot or too cold, the wind chill's too chilly, we have to let people know when these conditions are moving in so people don't die of exposure outside. Frost and freeze conditions, so the farmers can keep things safe when we're in the spring season and the fall season. If we get an exceptionally late season freeze in the springtime, they need to know that so they can keep their vegetation safe from the extreme temperatures. And then even fog, which can be a big transportation problem, especially when it gets very thick. So that's another thing that we warn through. So all these weather threats that are out there, we're constantly monitoring for, and then we're trying to get every little bit of advance notice we can for the community so that you all can stay safe from these weather threats as they're moving in. So how do we do that? Let's go to the next slide and talk specifically about these weather hazards that we get and how we warn people for them. So we use the watch warning system in the National Weather Service, and we have for a long time now. And the easy way to remember the difference between a watch and a warning is the watch is keep a watch out, keep a watch on things because there's a potential for something to happen. Versus the warning is the red light. It's saying, hey, this is happening. What are you doing about it? It's the action statement. So let's use your kid's graduation as an example. If there's a severe thunderstorm watch that afternoon, you're going to know to keep tabs on the weather, know what you're going to do if a big storm sweeps in while the ceremony is outside. But it's not going to cause you to cancel things generally because it's only the potential that it can happen. But then once we see an individual storm, an individual severe thunderstorm, using radar and satellite and all these great tools we have at the National Weather Service, this storm we designate as severe. We're expecting it's going to cause damaging winds, large hail. So we'll issue a severe thunderstorm warning for these communities over the next 30 or 45 minutes. So that's the action statement that lets everybody at graduation know, hey, there's a storm moving in. Let's get to safety. So again, a watch is to keep a watch on things, be prepared. A warning is this is happening. What are you doing about it to keep yourself safe? And we use that for everything, weather threat wise, from hurricanes, winter storms, tornadoes, flash flooding, everything. So that's the basic system that we use that you need to be aware of. Watch is to keep a watch out, and then a warning is to jump into action. We do have different forecasts for different user groups across our area, and the hazard aspect of this kind of overarches all of this. So for all these weather threats that we have, whether you're a boater or aviation or a public person or a firefighter, there's a tornado coming, everybody wants to know. So hazards kind of overarch everything. But the public forecast that we issue for everybody, it's available on weather.gov all the time, and it's constantly being updated 24 hours a day. If you click on your location on weather.gov, it pulls up the public forecast, which is what most people want to know. Is it going to rain? What's the temperature going to be like today? Are the winds going to be strong? Is it going to be sunny or cloudy? The basic things that people want to know. But in addition to those public forecasts that go out through 7 days of how the weather is going to evolve over the next 7 days, we also have to have some very specific forecasts for specific groups. One of those is aviation. So for all the pilots that take off and land out of national and BWI and airports all across the country, they need to know very specific things. They need to know how high are the clouds going to be. If the visibility is restricted by fog, how much? How many miles are they able to see ahead of them as they're taking off and landing? How are the winds not just direction, but how are the winds and wind speed going to change as we go through the day. So it might cause our landing configuration to change at the airport. So we issue aviation forecasts specifically for them. We also issue hydrology specific forecasts for tidal levels, for river levels. We issue marine forecasts for ships at sea. We issued wildland fire support for the firefighters that battle all these major wildfires, in particular in the western part of the country, but even here from time to time. And then we also have direct on-site support where the Weather Service actually puts somebody in an emergency operations center, a meteorologist in an emergency operations center, so that they have the full power of the National Weather Service right there in their emergency center to make sure that they're making good decisions in the advance of the storm as it's coming through and after it's passed. It kind of shows what you get if you go to weather.gov and click on your spot. It'll actually show you not only that today is going to be sunny and it's going to get up to 75 degrees or whatever, but you can actually see an hour by hour accounting of what the temperature is going to be at 2 o'clock. What's the temperature going to be at 5 o'clock? When does the chance of rain really come up during the afternoon? So it allows you to be more efficient with your daily planning and knowing, when the weather is going to change enough that it might cause you to alter something that you're doing. So we have this hour by hour forecast that's available for any location across the country, right from weather.gov. And that's the public forecast. Again, if you go to the aviation forecast, the terminal aerodrome forecasts, or the TAFs as we call them, are for specific airports across the country. And they say for the next 3 hours, the winds are going to be from this direction at this speed. There's going to be this limitation on visibility or not. The clouds are going to be either clear sky or scattered or overcast. And not only that, but how high the base of those clouds are. So when they're landing, they know when they're going to break out of the clouds and be able to see the runway ahead of them. So these specific 24 to 30 hour forecasts are getting generated for airports all across the country, all across the world. And we talk a little bit more about hydrology specific forecasts that we issue. Since weather obviously drives how high the river is going to get to because of rainfall, the Weather Service ends up forecasting the height of how high the Mississippi is going to rise, or more locally here, how high the Potomac is going to rise, or even some of the smaller tributaries that we have, like the Monocacy River near Frederick, the Pecos Creek out in Virginia and West Virginia. We have to let people know how high those are going to get so that they know that when it gets to, let's say, 7.5 feet, there starts to be road flooding. This road is going to be closed down because it's going to be overrun by water. Or if it gets to 9 feet, it's going into these people's homes. So we have the observations of how high the river is now, but we also forecast for a lot of those points how high it's going to get. And that allows people to plan, sandbag, evacuate, whatever it is they're going to do from these river threats that are driven by weather threats. In the marine forecast, we give location-specific information for, again, what the direction and speed of the wind, because obviously that's important, but also important with that is how high are the waves going to be. And in a body of water like the Chesapeake Bay or the tidal Potomac, it's almost all wind-driven waves. If it's 20-mile-an-hour winds, the waves are going to be this high. If it's 30-mile-an-hour winds, 30-knot winds, the waves are going to be this high. When we get out into the ocean, it's not only wind-driven waves, but it's also the swells from distant storms that are out there. So the Weather Service has to let people know not only what the waves are going to be, but how high the seas are going to be from these distant storms that are potentially even hundreds of miles away from where you are. So through this system of marine forecasters, if anybody's heading out onto the waters, they can check the forecast and see, all right, this is what I can expect. And then if there's actually a storm that spins up over a marine area, we issue specific special marine warnings just for those boaters in a particular spot and say, hey, a storm spinning up right in this area. It's probably going to cause some gusty winds. It could capsize you. Be very careful or get out of the area if you can. So that's kind of how we keep the people at sea safe, is through the forecasting and through the warnings working in tandem. Let's go to tidal forecast and coastal flooding. So in addition to rivers being driven by rainfall that's happened over the country, tides are driven generally by two things. It's driven by astronomy, where the sun and the moon are, and that's something that can be forecast long time in advance. But a lot of it's also driven by the weather. If there's an onshore flow onto the coastline, it's going to bring the tides up. The stronger that is, the higher the tide is going to rise up on top of that. So you're almost always going to have the rise and the fall of the tide, from high tide down to low tide. But sometimes when the weather conditions are right, that tide, when it comes up, will rise much higher than it typically does without the aid of some of these weather things that are out there and storms that are out there. One of the most known is storm surges that come with hurricanes. If you have a big hurricane that's coming on shore, it's going to bring an extremely high tide over part of the area that it makes landfall on, because of all that wind piling up the water on the shoreline and causing an extremely high tide. So not only do we monitor these tides, but especially here in the mid-Atlantic and on the eastern seaboard, we forecast how high are these tides going to be the next several cycles. So again, communities can prepare. They can sandbag, they can evacuate, they can get businesses ready that are right along low-lying areas along the shoreline. Or if it's a hurricane or something that's really going to bring the tides up to exceptional levels, evacuating people, getting people out of harm's way, knowing how high that water is going to get is such a key thing, because water is such a powerful force. For wildland fire support, the Weather Service does work very closely with land management agencies, with people that do all the wildfire fighting across the country. And again, this is much more prevalent in the western United States than it is in the eastern US, but we do have it here from time to time as well. And they want very specific information. They want, again, the winds. They want how high the smoke is going to mix into the atmosphere, or whether it's going to get trapped down at the surface, what the humidity is, how the humidity and the winds will interact to potentially create, explosive fire conditions if the humidities are very low and the winds are very strong, and the fires can really blow up. So we create forecasts twice a day out of the forecast office, letting these fire managers know what the conditions are and how they're expected to change over the next couple of days. And for these bigger fires that happen across the country, again, we'll actually put what we call an incident meteorologist right in with the firefighters, so that they can brief them routinely and let them know how conditions are going to change through the day, and make them efficient and safe at fighting that big wildland fire. And then a kind of a related part of that is direct on-site support that the National Weather Service gives to emergency management across the country. So if there is a big major event that's going on, or if there is something that's going to put a lot of people in harm's way, or let's say a weather disaster is coming towards a particular area, the Weather Service can put a meteorologist right there in the Emergency Operations Center. So again, they can routinely keep everybody up to date, answer any questions, and make sure that that region is aware and as protected as they can be from these weather threats as they come in. So kind of getting towards the back end of the presentation here, so we've gone over the decades, over the centuries, from no forecast to having a forecast in your phone, your pocket forecast. So we can't prevent weather tragedies from happening and big weather events from happening. But if we're ready for them, if people are aware of them, if people have advance notice, then tragedy can often be avoided, and we can mitigate it to lesser amounts of property damage and hopefully keeping everybody safe. Because just having that advance notice of something coming, staying aware, can save you, it can save your family's life and people in your community as well. So it's been a dramatic advancement in weather forecasting and weather safety, not only in this country, but across the developed world, to give people this advance notice of weather disasters before they happen. So let's check a couple of things here. If you do a couple things from this presentation here today, routinely check weather.gov, your forecast, whether there's any watches and warnings, any hazards that are coming, and what routinely means, if that's once a day for you, if that's a couple of times a day for you, or even just, poking at every now and again just to get familiar with it. It's a great way to stay on top of not only what the day-to-day weather is, but if there's any threats that are out there if we're monitoring. And then the other thing is to get National Weather Service warnings immediately to your phone, your email, to you in particular. Have an app. There's many private sector apps that are out there. The U.S. FEMA has a weather app where you can put in your location, and if there's a National Weather Service warning issued for your county, the FEMA app will give it to you directly. The Red Cross Emergency app is another one, but there's no shortage of weather apps that are out there that'll give you National Weather Service warnings as soon as they're issued for your particular spot. So you don't have to hear of weather warnings that are 40, 50, 100 miles away from you. It zones it in right to the area that you care about. But if you get those weather warnings directly to you and have a couple of different ways, a little bit of redundancy built in so that if one thing fails, you still get the warning. That goes so far into keeping yourself and your family and your community safe, because awareness is everything when it comes to weather safety. So how does this get driven all across the country? How does the Weather Service do this? How does this actually happen? The National Weather Service is broken up into forecast offices across the country, and I liken it to the FBI, because there's national headquarters that's downtown, but there's field offices all across the country, and each one of those has a particular area of the country that they're concerned with and they watch out for 24 hours a day. And whether it's a winter storm that we see spin up 7 days from now, or a thunderstorm that spins up at 3 o'clock in the morning on an overnight shift, we're getting out as much advance notice as we can to the community to let people know of these things before they're happening. So that wherever you are in the country, whether you're home here in Washington and the National Weather Service Baltimore, Washington office is watching over you, or if you're visiting your relatives out in Topeka, or you're visiting your friends out in San Diego, wherever you go in the country, there's a forecast office that's watching out for that area and giving people advance notice for weather threats as they're coming in, and also giving you that 7-day forecast as to what's going to happen with the weather as we change from day to day. So the local experts are at each of those individual forecast office, but they lean on national experts. And it's a really teamwork between the local expertise at the local forecast office and the national threat experts at the national threat centers that really allows for such a great teamwork and a great weather service to the United States, because the people that are experts on particular threats are giving information to the people that are experts on their local area. You can see some of these weather centers, national weather centers that we have within the National Weather Service. And the most known one is, of course, the National Hurricane Center down in Miami. And they are exceptionally talented forecasters at forecasting where hurricanes are going to go and how strong they're going to be. But when it comes to what that means for how high the Potomac's going to get, or how much rainfall we're going to get on the Blue Ridge versus to the east of the Blue Ridge, the local details come from the individual forecast offices. So again, we work together to give you that great forecast as we're moving towards a hurricane. Other ones are the Storm Prediction Center out in Norman, Oklahoma, which are the experts in tornadoes and severe thunderstorms. There's also the Space Weather Prediction Center in Boulder that's looking at solar flares. There's the Aviation Weather Center that's aviation weather experts in Kansas City. But again, it's all about these national experts working together with the local experts to give people the best service that we can and give people as much advance notice as we can. We also rely on some key partnerships. And the Weather Service, in the end, is really an information source. We're watching the weather and we're getting you the forecast. We're giving you the warnings on weather threats as they're moving in. But we rely on the media and the broadcast meteorologists, social media, all that to get information from us out to the community. If we were just relying on our small little microphone to get information out to everybody within the area, we would fail miserably because we don't have that direct connection. But you know who does? A lot of our partners, the counties, the states, the broadcasters, the social media, local experts. They can take our information and they can springboard it through the community and tailor it to their specific communities. So again, that's very much a partnership and a teamwork effort to get information from us into the community. And then there's also the tight partnership with emergency management at the federal and regional and state and even county level, and even smaller granularity than that. We're working with emergency managers all the time so that they can get their jurisdiction, their area, their state, whatever it is, prepared before the event comes. As the event's coming through, they're making sure that they're all ready to go. So when the event goes through, it's as least impactful as we can make it. And then on the other side, after the storm passes, recovering from it. So emergency management and the Weather Service are very much tied at the hip, because it's our information that allows emergency management to make sure the community is safe from, responds to, and rebounds from weather disasters as quickly as possible. So all of those groups are working together behind the scenes to make sure that, again, everybody's staying safe. So where can I find all this? Let's get to the bottom line here. Weather.gov/Washington here in the Washington metro area, or wherever you are in the country. If you just type weather.gov and click on your location, you can pull up the forecast. You can see any watches or warnings that are in effect for the area. At the bottom of the pages, you'll see the Twitter feeds and the social media feeds, which will have the message of the day that you can see online, or it'll give you an avenue you can follow them. So again, that information will follow you as you go through your daily life in the days ahead. So all of that information is available to you, and it's a great way to stay weather aware and to stay weather safe. Here, the National Weather Service is here to help you. You know the power that your smartphone has and what it's able to do in this day and age. That bottom picture is one of the supercomputers that the National Weather Service has to run these global supercomputer models. So if you think about how much computing power is in this, how much computing power is in a computer that still fills the room in 2021? It's the amount of calculations, the amount of weather information that it's able to process. And again, this is just one of several supercomputing centers across the world. All of these are working to advance human society and our understanding of weather, our knowledge of weather threats. And in the end, it's all just about keeping us safe from these weather threats, whatever it is, as they're moving into the area. So after they move through, we all come out of our shelters, come out of our houses. Everybody's okay. Okay, whatever happened to property and things, we can rebuild. Hopefully we did mitigation and sandbagged and things like that to protect property as much as we can. But it all just comes down to awareness and knowledge of these weather threats, and everybody will hopefully be able to stay safe as we go through these events in the future. So finishing up on the last slide, harness the power of all that. All these supercomputers, all this knowledge base for meteorologists across the country. Harness the power of the National Weather Service for you. We're here 24/7, every day of the year. Christmas morning at 3 a.m, Thanksgiving afternoon, New Year's at midnight. No matter when it is, there's forecasters at the National Weather Service that are constantly watching the weather. All you have to do is connect to us, make sure that you're getting weather warnings from us, stay on top of the weather, especially when you're going outside and doing things where weather is much more of a factor. And through all this, we'll help keep each other safe and help keep each other informed. So thank you all for your time today. And I encourage you to check out weather.gov, check out our Twitter and Facebook accounts, and just start getting fascinated with the weather, just like I am.
Chris, thank you very much. I got a quick question for you. Something you had said about the weather balloons.
Yes.
With today's technology of drones and all that, would that be able to work as well? Wouldn't they be a slight bit cheaper if you put it on top of a drone?
So these weather balloons have to go up to about 100,000 feet up in the sky. So they're going through the entire weather producing section of the atmosphere. So I guess with drones, we are starting to use drones for what they can do, especially in terms of like storm surveying and tornado surveying and things like that. But in terms of routine weather observations, for what these have to do, I don't think that they're quite there in terms of their capabilities, or how much it would cost to do that all across the country. But it is an up and coming technology, and I don't doubt that that's going to be a piece of the puzzle as we go forward.
Okay, now I know other people are going to probably have questions, and they'll shoot them to us. We'll forward them to you, and you will answer them, I'm assuming?
Yes.
Excellent. I have one personal question, something I noticed on my motorcycle the other day.
Yeah.
Beyond the fact I knew it had a weather band, I was kind of impressed that it did have the NOAA signal, and they're like, NOAA's weather today is. I started cracking up going, I'm going to be interviewing this guy tomorrow. And I was like, this is great, because it was telling me a storm's coming. I'm like, let me make it home before this hits.
Yeah, great. No, weather radio is another one of those old technologies that's been around, but is really resilient, a lot more than a lot of technology is. And it just 24 hours a day reads the forecast, the observations. But if there's a warning, you know, a severe thunderstorm warning gets issued, it'll buzz through on that, and that's a great way to get weather warnings out as well. So weather radio is just a technology that's been around a long time, but is a great way to get weather information too.